letting x and y be i.i.d. uniform over 0 and 1. First going to compute the covariance of x plus y and then x minus y. After that, we're going to assess whether these two random variables are independent. Okay, so compute the covariance. The covariance is x plus y, x minus y, and that by using the properties of covariance, we can multiply and think about this as sort of crosswise multiplication, where we start with little x, with x here, multiply it with x, and then with y. So covariance of xx, covariance of xy, then negative, and then plus covariance of yx, then negative covariance of y squared, y with itself. So now we did x covariance, now xy. The negative comes from the fact that y here is negative. And then covariance of y, x, and then there's another negative covariance y with itself. Now the covariance with itself is just the variance. So this is the variance of x, and that's the variance of y. And because these two variables are i.i.d, so they're identically distributed and independent of each other, so they will have the same variance. So they cancel out. They cancel out, and this with this, and this just cancels out. So we end up with the covariance of these two sum and negatives having covariance 0. Okay, now we're asked to assess whether they are independent. That's a interesting question. Well, they seem to be quite dependent, right? Because we have two random variables, x plus y, which is one random variable, and then this is another one, and they are indeed a construction of the two underlying same variables. But how do we show that they are dependent, if now that is our hypothesis? Well, one way to think about this is that let's look at x plus y and think about what the support of that is, and then think about what x minus y, and then what the support of that. And we only have to find one case where they are dependent to show that they are dependent for the whole random variable, right? So independence means that for all values, things have to be independent. Okay, so let's see then. So when assume that x and y is, they go to 1, so because x has a support 0 to 1, it can take on values close to 1, same with y, and then that would yield a value of 2 for x plus y. So when x approaches 1, y approaches 1, these things have to be this have to be 2. But then in that case, we know that if this is 1 and this is 1, this will approach 0. So we see already that there is some dependence here, and we can then say that the probability of x minus y, and the way to think about this is perhaps to say, you know, for some small epsilon, let's see, just some more space. So for small epsilon, we can bound the conditional distribution of x minus y as we let x plus y approach 2. Well, basically we are constraining it to 2 here. Well, this means that as x plus y goes to 2, then little epsilon, we can be with very high certainty know that x minus y goes to 0 with probability 1. Like so. And hence we've shown that these two random variables have to be dependent.